So still at TCT 2017 and still with Joe Prusa.
Right.
This time we're going to talk about your Einsy board that you developed basically with Ultimachine for use on the Mark III. So what changed? What's the big new features?
So basically everything changed. It's a new evolution of the Mini RAMBo, but we needed to add some more features and keep it the same size. But there's no more space on the board. If you look at the picture, it's so crowded. But we can start with the big things. So it features dynamic 2130 drivers, which are completely integrated. They are talking over SPI with the microprocessor, so we can set everything up as we need to. I've seen some on the silent step sticks and stuff like that, but they are used in the dumb mode, which doesn't allow to set other features than just current. We can set everything.
Are you still giving them the step and direction signals traditionally?
Yes. That would be quite hard, but we can set them up and monitor everything through SPI. So this gives us the option to use the stall guard, which we use for the sensorless homing. Basically, the drivers can detect increased current going to the motors, and when they stop, we find out that the start of the axis. And also, if it catches on the print, we can then rehome.
Right. And I've seen someone comment that you're still using soldered-in drivers. Do you see that as an issue that these might fail at some time? Have you wrecked one of these drivers yet?
We did on the very first version where wrong resistors were done, but on the latest revision, no. And I don't know where this thing with the replaceable drivers is from. It's bullshit. Because you have to heatsink it on such a small PCBs. These drivers are designed to be cooled down via thermal vias under the driver, and the heat should be spread into the board. And you can see it. You can see it here. All these are thermal vias.
Yeah. And you are now using a 6-layer board, so you have 6 layers of copper in here. Let's just keep it on that side for a second. And basically, the bottommost layer, you can probably see it here, that is a huge ground plane. So all this area, all this PCB area is going to be used for cooling the drivers. And the dynamic ones are running relatively cool, so I think that should be more than enough to keep these cool.
Yeah, obviously. And I mean, there's a much higher chance you blow the replaceable driver than this. On the 36,000 Mark IIs, we had so very few blown drivers.
And that was all the Allegro chips. That wasn't Trinamics yet.
Yes, but I think it will be the same, and replacing. And especially if you buy it from us and you have a blown driver, we will replace the board. So.
And on the topic of blowing stuff out, so you still have the automotive fuses in here. I think it's a few more than last time.
No. And there are 3. Okay. One is for the heated bed, one for extruder, and one for the rest. And we have a nice little feature where we can actually measure the voltage, so we know if the fuse was blown, and we know which one. So if you are, for example, a kit builder and you short something out, the printer will tell you that the fuse was blown and you need to replace it, because we've had hard time sometimes troubleshooting. My heat bed doesn't work.
And the printer just gives you a message, okay, fuse blown, X, Y.
Yeah. Even though we moved to 24 volts, we still changed to the screw terminals. They are same as on the power supply. It just gives users less chance to not connect them properly. And we actually went a step further. And right in here is an ambient thermistor on the big ground plane, and if you screw in the terminal very poorly, it will heat up a bit, even though it's on 24 volts and currents are quite low. And we can sense that with the ambient thermistor, that the connectors are overheating. And also we use the ambient thermistor because a lot of people print in cold garages. You mentioned that your workshop has in the winter lower temperature, so which could trigger min temp errors. So we can work around with the ambient thermistor.
So why not just set min temp a bit high, lower to 5 degrees or something? Is there a reliability issue?
That's because of the thermistor which are used by E3D. They are not very sensitive, and also the parts don't allow to read at such low temperatures, and that's just because of the because of the heritage, how it was made, so we can keep the same tables. But also, it can be used if somebody places the printer in
in an enclosure, in a hot box,
and it's about to overheat, and it might be unsafe. So we can kill the print, and making it safer. I think it's a good way to go.
All right. So you mentioned you have switched to 24 volt for the entire system, heated bed, extruder, fans, everything is 24 volt now. But you're sticking with 8-bit versus 32-bit boards. Why is that?
I mean, it works so well for us. With such a big release, we didn't want to change too much stuff. And right now, we can co-develop the firmware for all the Mark IIs, Mark 1s, Mark 0s, and Mark 3s. Because there's still, the motion planning, which is updated. There's very little left of Marley, maybe the G-code parser. It is now doing integer mod instead of floating point, so it's much faster. It is oversampling the extruder steps, and that is very nice. The electronic is actually, even though we mentioned 256 microstepping, the electronics is still using 16 microstepping resolution, and the drivers multiplied by that to make it smoother. So this gives, for us, there's no need to go to 32-bit. And especially with the accessory port we will be talking about a bit later, you can plug the smart part into it and have the printer connected by it.
Well, let's actually talk about that right now. So if we flip this, or I think we have one somewhere.
Okay, so this one is with the Raspberry Pi Zero W, and this one is without. So there's an accessory port. And basically, it has the power, it has the serial, it has the SPI, it has 5 volt, 24 volt, it has the power panic signal, basically everything you need. And so I've seen a few mentions about the Raspberry Pi Zero W. We tested it, it works. But if you don't like this one, you can actually still take advantage of the port, and you can just make connector cable, which you will plug into the accessory port, and then you plug it to the Raspberry Pi 3 or whatever you like. So it still gives you a much nicer thing than you had before, where you had the USB cable and another power supply for the Raspberry Pi. But this can be taken from the board now.
Yeah. So that is the big difference. You are now breaking out those signals that you can directly interface to without going through USB. But of course, the option is still there to go through the USB port if you want to do that. If you want to plug in something that doesn't fit that slot,
this is just much nicer. I mean, this fits in the case, and we have a distribution which actually creates a hotspot. You can connect to it and do whatever you want. We didn't see much problems with the Raspberry Pi Zero W.
So are you going to fix the Wi-Fi driver?
I don't know. We never had issues with the Wi-Fi driver, but yeah. I mean, there will be many guides, I guess, by the community members how to connect different kind of boards, and we actually use the accessory port. We have special monitors on our farm, on each station for the printer, which plugs into these ports, and it sends diagnostic data to the print farm monitoring system.
You guys really are crazy.
Yes,
confirmed.
If you ever visit our factory, I can show you all the guts.
Right. So what else do we have in here?
There's so much stuff. So there are new connectors for all the new sensors. So the fans are 3 pins, so we can detect the RPM. Connector for the new Pinda Pro with the thermistor. Also, we have the power panic. It connects special signal from the power supply, which basically tells it that the mains are out. And
so yeah, how does the sequence work for that? Because if you just keep printing, it's going to be out pretty soon, right?
Yes. So basically, when we tried to connect this signal into the interrupt on the processor, it was too slow. We had like 30 milliseconds of power left in the caps in the power supply.
And just to clarify this, you're not like constantly saving which points the print is on. You're not like constantly writing something. You are actually writing that at the moment when the power goes out.
Yeah, that would damage the EEPROM very quickly. So it has like 100,000 write cycles.
I think it's less, but
Yes, but I mean, you could have 100 power losses a day for 3 years and still be fine. But actually, when the power is stripped, there is a comparator, and it immediately by hardware shuts down the heated bed and the heater, and that leaves enough energy for like between 300 and 500 milliseconds to save the position, save all the data, and actually go up with the extruder for 2 millimeters. Yeah, and it depends on the power supply, the temperature and stuff. We even try to go out of the print, and sometimes we get even to the end of the axis, but that's not necessary. We always manage to go up at least 2 millimeters, and so you don't melt the print while the printer is stuck. So if the power actually trips and is back up rather quickly, and the bed temperature doesn't go 5 degrees below the target, it will continue automatically. Otherwise, it will start heating, but it will ask user to verify that the print isn't unstuck. So, for example, if you are doing ABS and the print cools down completely, the parts usually pop out. And
there's a certain spectrum of what's still acceptable, what's not acceptable
it's
anymore.
Better for user to check it if it stayed for a long time. But I mean, if you have a lot of brownouts, I believe that's what they are called. It just dims the light. Yeah, you can actually. You don't even have to know. We had to make a counter in the firmware, which tells you how many failures you had.
So with all this new sensing and like smartness features, I am a bit worried about that you might be putting too much intelligence in there, and that the printer might start working against you. How has that been working out for you? Have you been running into like any failures that you weren't expecting? Has your life become harder instead of easier?
No, actually, we can do so much such nice stuff. Like you don't have to use the menu to load the filament. You can just slide the filament in. Printer will ask.
That is awesome.
And once you get used to these things, it's rather hard to go back. But your point is right. These sensors are all new, so we don't know how well they will work in 2 hours, 2-3 years. So it's possible to turn them off in the firmware.
If you don't want them, you can go in there and print just like with a Mark II, basically.
Yes, basically yes. And yeah, I'm pretty sure I forgot something about the board, but
I guess that the rest of the info is up on the website, right?
Yes, and I think the Ultimachine will be publishing the layouts rather soon.
All right, so again, that the board is still open source. It is still made by Ultimachine, so you can go to GitHub, download the files, and if you want to make your own, you can do that.
Yes, but as I said, the board is pretty packed.
Yeah, someone commented that there's not much space, and that is true. All right, thank you for your time.
Thank you.
And see you around.
Bye. Oh man, I need to shower.